up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. Oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. Hey, it's too late to try to go contain it. A generation fueled by creation. We live lives on a small screen nation. We control the airwaves, no negotiation. I refuse to think we need saving. Something good will come from creation. And when we think that the world is too anxious, we'll adapt, evolve, survive, and save it. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. Oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. Hey, oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong.
This is Houston Control. Checking for backup. Backup initiated. Locking down all ports. Clear. And we are good to go.
Well, Roger Houston, we've got the commo going 5x5 coming high above you in your imagination in the International Fake Station. Excuse my voice. I just took a massive bong hit. Welcome, everybody. Good. We got a good number of people coming in already. We're going to be joined by a special guest this evening, a globe proponent from the battlefields of the Twitter debate ground, for lack of a better way to put it. We're going to be joined by, he's known as Conspiracy Smasher on Twitter. God, I'm starting to sound like Robert Kennedy Jr. Here we go. Be all right. Shouldn't make fun of that guy. He's doing some good stuff, I guess. Anyway, we'll be being joined by him. He uses a militant penguin. If you noticed by the thumbnail of this video, I used his avatar, and I think it's ironic. I don't think he's aware of our little joke, or is it a joke, that we have going on over here about the penguins actually being the Illuminati, and that they are actually the ones running the show. So I think that's pretty funny. Anyway, let me take a look and see who all I've got in here. I'm going to have to start the Rumble side up too so that I can see it. Let me just do that real quick, because we are streaming on Twitter. We're streaming on Twitter, Rumble, and my keyboard is acting fucking stupid, man. Well, give it just a minute here. God bless it. I don't know what the hell is going on with this keyboard. I'm about to fucking shit can it and grab my other one and just plug it in, because this thing's really giving me a rough way to go. I don't know why it wants to do this. I keep having to turn the fucking keyboard off and then turn it back on. It might need another battery or something. I don't know. We'll find out here in just a minute. Is that letting me do anything now? Let me see. Nope. Okay, so I'm keyboardless for just the moment. Anyway, I'll be able to take a look here in the chat. Right now, I've got Access Monday, Clever Guy Discoveries, Gen C Tordai, hello, Plowboy6756, Smoking in G Sharp and ZXL Master. That's just the people in the chat. I'm showing 18 watching now. Let me get over to this thing, and we're going to fix our little keyboard problem here in just a hot fucking minute. So I guess Did I turn this thing back on? Or let's see if that changes. No. You know what I'm going to do, though? I'm going to change the battery in this. There we go. We got our tech department grabbing up some batteries for us here real quick, and we'll see if that solves the problem. So anyway, he'll be joining us tonight. I have an interesting take on something. Some of you may have heard me talk about it before, and that was the idea of if you went inside of a planetarium, okay, and had it duplicate the sky exactly as it is at the time and location where you're at, and then use the sextant inside of that planetarium, and then compare it to the readings that you get outside the planetarium on the very same objects in the sky, there will be no difference in the measurements that you get. So this idea, I've heard people on these forums talk about you can use a sextant to tell the distance to these stars and shit and these heavenly bodies, and that's not the case at all. Here they come. They had to blast this off from down there at good old Cape Canaveral. Thank you. Whoops. You got a gravity pocket. Can't have those fucking gravity pockets. All right, we're going to try this, and hopefully this works. Oops, wrong battery. That was one of the ones I just took out. Dipshit Dave. Let's see what we got going on here. So hopefully he's supposed to join us here at 11 Eastern time. Of course, that'll be 10 o'clock his time. Let's see if that changes anything with what we got going on up here. Nope, it has not changed a damn thing. So what we're going to do is turn this fucking keyboard. Let's make sure. Give it a chance. Oh, wait, maybe I did get some. Nope. Wait, there it goes. There we go. Hey, fixed it. Technographical problems solved. Now we're going to check out over on our Rumble side. Sorry about that, y'all. Let me go to my channel over here. And it's that one does have an avatar of a militant penguin as well. So I don't know. Think about that little mind experiment I just did there. Got some pretty cool stuff I can show you here while we're waiting, kind of getting some people in here. As I said, we are live right now on Rumble, YouTube, as well as Twitter. So let me see if I can find that, what I was looking for. I'm going to sort these by type, and then I can work my way down here. Okay. So part of this debate has been on perspective. One of the things that got me into this whole argument that's going on there is based on the idea of, one, this is where I started with this, that the two things that have to be proven and to have your globe in space or whatever, or even a globe at all, is first you have to prove convexity. Okay. These are two very important things. We have not seen, nor have we measured any convexity. For some reason, people think that the horizon that you see, the apparent horizon, is somehow the physical edge of a curve, and they don't look around them and notice. I mean, it's ludicrous. It really is. Your eyesight has a limit. This is why, with the aid of telephoto lenses, we can bring things back in. So we've been through this, and we'll show some examples of that tonight too, that there is no proof of any convexity. Now, this guy goes, so him or one of the others, if I got them confused, I'm sorry, they all start looking alike to me because their arguments almost come like right. Well, their answers and their arguments don't come from them. Okay. Most often I see a lot of these guys that are, intelligent through proxy. Okay. In other words, because someone that they deem as smart has said it, they regurgitate it. They don't really look into it to see if it makes any sense. Okay. And they just regurgitate some bullshit and don't realize that there's a bunch of assumptive values involved with what these people did to calculate this. Much like when we dissected the carbon-14 dating, and we found out what a joke that shit really is, right? So they base the fact, they think that if they can memorize or even present what someone else has said, then that by proxy makes them intelligent. So another part of this discussion was having an atmosphere, a gas pressure system within a vacuum without containment. Okay, try to have any pressurized gas in any environment, that have it pressurized to a degree more than what it is around it, and equalization is going to happen without containment. Okay, as soon as that containment is breached, the gases inside go in violently and rapidly to fill the empty spaces. This is why the whole idea of gas balls forming in a fucking vacuum, much less catching fire for some reason, is just ridiculous. It's stupid. And I had another guy tell me, well, you can see this atmosphere on Jupiter. I'm like, how in the fuck do you know that fuzzy shit around the outside is an atmosphere? And how in the hell does a gas planet have an atmosphere? That's what? Okay. So that's part of the argument. Another one is telling the distance to some of our most basic celestial objects, the sun, the moon. How was that calculated? I mean, we're told in the heliocentric model that the sun is 93 million miles away, approximately 8.5 light minutes. There's Austin Murphy has made it. You're late. I'm going to mark you tardy, Austin. No, I'm just messing with you. Just a note out there to my moderators, anybody out there that's moderators, I want to tell you, don't, be liberal. Don't be timing people out unless they're just saying stupid ass things. I mean, real, and of course, with any kind of what YouTube would deem as hate speech, or that kind of thing. So just use your discretion. I'm hoping you have good judgment. Okay, so we want to go with that. So in order to tell the distance, this is what they're telling me, and they cannot see their own circular reasoning. All right. So the whole question posed to begin with is, how do you tell the distance of the sun? Okay. He said, well, you can look at it from 2 points and measure the distance between those 2 points, and that'll tell you how big and how far away it is. And that's absolutely not true at all, because there's nothing to reference it to. You're working in 3-dimensional space without anything to of comparison, nothing of comparative size. But wait, this is where it gets better, because then they say, well, we can watch Venus go in front of the sun. And I said, yeah, okay, so what? And they says, well, by taking the orbital radius of Venus. And I'm like, wait, how do you have an orbital radius of Venus when the very thing that you claim that it's orbiting is what's in question? That makes no sense. They flip-flop back and forth, and it's just the most ridiculous thing you ever heard. Guy, and they always want to just post and send articles, right? They don't want to talk reason or anything else like that. They talk articles. So they send an article. I read this article. It says, how we tell the distance of the sun to the moon. And I was like, are you shitting me? Right off the first paragraph in this shit is all this speculative crap. Like, the moon seems large, so that means it must be close. And the sun is very bright, so that means it must be very far away. Why the fuck does it mean that? It doesn't mean that at all. You start off with a false premise, you're going to get a false conclusion. My God. And there again, you could do the same thing, like I said, in the planetarium. They could project a sun in the sky and everything else, a perfect model of what you experience outside at the exact same time, in the exact same location, at the place they're projecting it in, inside of like a planetarium, a dome structure, whatever. And you can go and get the same measurement of the sun. We know that the one inside the planetarium is only a few yards away. Or if it's big enough, maybe just a couple hundred feet. That's all farther it is away, but it looks exactly as the same as the one you're looking at outside that's supposedly 93 million miles away. So there you have the dilemma. So what do you gauge that size by? So you find this nonsense in their fucking in their calculations. And this is one of the things I've been trying to point out. So we have to have convexity. We don't see convexity. We don't measure any convexity. No matter how high we go, we don't see any convexity whatsoever, unless it's by a manipulated lens. Okay. The second thing is we have to be able to prove, and an equation is not proof. Okay. An equation is not proof. You have to prove that a gas pressure system can exist within a vacuum without containment. If you think that gravity can hold a gas against equalization of an outside pressure, then you believe that when you open a Pepsi or a beer, that it's not going to go psh. Now, if it's flat, it won't. And why is it flat? Because the pressure has somehow equalized through the porosity of the metal and the seals with the outside. But that rarely happens. Only after it's been set exposed to the outside element, to the outside pressure, does it become what we call flat, no longer pressurized. Okay. We also have to take into consideration that the root word of pressure is press. Okay. So they want to argue that a graduated pressure system, with the high pressure nearest the earth and the lower pressure at the outside extremities, is a result of the gases pushing down on each other because of gravity. Well, we just saw that gravity does not stop equalization. They also try to present the idea that this graduated atmosphere is somehow in separate layers. It's not. You have to look at it that there's different mixtures of the same and of different gases the higher you go in altitude, based on the buoyancy or density of that material. That's all. That is all. Okay. It's not because of any gravity, because if it was from gravity, we would be able to prove that gravity can stop equalization of pressure systems, and it cannot. We already know this. So you look and they say, okay, so this thing goes all the way out. They say it graduates out to a nothing. It goes out to just fucking nothing, right? So think about that. At that very last fucking layer, where that 0.000001 very light pressure is at against the vacuum of space, we still have what's called pressure, which comes from the word press. So what is pressing against the gas? Space? Of course not. This can only mean that this is a contained system. There is no way out of that until proven otherwise. It remains closed. Now they always want to say, "Oh, well, at what altitude is your dome? At what altitude does your dome go?" All right, well, I don't know. I've never been up there. But one has to exist. Some type of enclosement must exist, or the atmosphere could not, graduated or not. It could not exist. And there's no way around that. unless you can prove it. So I do have a clip here of Neil deGrasse Tyson actually saying such a thing, that things have to be proven. You know, you can't just go with an equation. I also had a discussion with this fella too about an interesting thing that happened to me in, hang on, let me find that. I need to turn this up. Find this about the, make just a second here. Oh, and then they always want to point to, yeah, we're going to get to that. But where's that one with old Neil? Where is he? Am I on the right one? Yeah. Oh, this is what I wanted to show. Yeah. Great. Hang on. Let me just a second here. All right. And then I can share this. Okay, so how high is it? I don't know. This rocket, which I find really interesting, suggests that it might be 72 miles, at least over Arizona. I think a dome would have an apex and then maybe diminish as it goes out, in altitude. But let me present this and show it to you. I'm going to share, this. There we go. This is the Go Fast rocket. Some of you have probably seen this before, but this is really interesting what happens. And it went up approximately 72 miles, had a camera on it that points back. You're going to see the Earth going away from the rocket, spinning. But what's interesting is pay attention to what happens and listen. Hopefully y'all can hear this. Let me make sure that I got the sound for it on. Yeah, I do. Everything's good. Blast off. Spinning so fast that it's actually, the frame rate of the camera is making it like stopgap like that, like wagon wheels do.
One thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth. There's no place to go. Rockets don't have brakes. It literally stopped. All of that angular momentum from the rotation of the rocket and the linear momentum from flying up just stopped. No, it had to. What would it hit? If it hit a solid surface, the rocket would have been destroyed. Most likely the camera too, so we wouldn't have the footage. And obviously, that's not the case.
Of course, this part right here is not actually, part of the Go Fast rocket. It's just there,
It's a deal. It's a long climb, all going back. And the force shatters the sky, bringing the ocean itself down into the stadium. Oh, Simpson just broke this dream's reality wide open.
I know we have still not shattered that highest and hardest glass ceiling, but someday someone will, and hopefully sooner than we might think right now.
So yeah, that's really interesting. And the full video from that rocket is interesting because as it's coming down, you'll see the sun as it's rotating. You'll see the sun over here. And then as it goes around, you'll keep seeing this little white ball back in the background. And if you zoom in and look, it's the moon. And the trouble is this was launched from Arizona, right? And the moon at that time, if you check the time and day, it was over New Zealand. I always think that's really cool. So our guest has joined us. I want to welcome up Conspiracy Smasher. Of course, if you've got a first name or something that you want to go by, you can call me Dave. But if you just want to go with your moniker, that's just as well too. Do you have a camera? Are you using a camera at all?
Let me get a camera set up for you.
What's up? You got a camera?
Yeah, can you hear me?
Yeah, I hear you. Just dandy, man.
Okay, cool. Let me get a camera set up for you. I thought I had one set up, but apparently not.
I've got a second camera here that I want to hook up so I can use a dual camera system. But I wanted to tell you something, Conspiracy Smasher. You might have missed when I was telling about it. On my channel, we've had this like running joke, or is it, right? That one of the reasons we can't go to Antarctica is because the penguin are actually the Illuminati, and that's why the elite try to dress like them and shit, you know. And of course we were just joking, but what was funny is I was joking about it, my stream starts getting pooched, right? And so every time we would run the joke about the penguins, man, our shit start getting pooched, and I was like, this is weird, right? And so the next day I see a thing in the news about where I think it was Norway had given an admiralty to a fucking penguin. And I'm like, you got to be shitting me. No way. And they actually had this. You see this penguin marching in front of these troops all standing at attention, and they salute him and shit. I was like, no way. So I played it on my next show. I said, y'all thought I was full of shit, right? Look at this. And so it's been a running joke. And if you see up in the right-hand corner of the screen there, I have my penguin with a sawed-off shotgun. I'm going to make some shirts that says, you ain't going, bro, with those on it. You're muted, incidentally, Conspiracy Smasher. And I don't have you muted. Okay. Something's happening. I see.
Okay, you can hear me, right?
Yeah, I hear you good.
My camera's not working. What the heck? Stop cam. Okay, just got that. Start cam. Huh, I guess we're not going to go camera today. Huh, that's weird.
Oh, I have to hit this on this thing. Trying to run two different things at one time. I have Ted Logan from, I'm sure you're familiar with. He's over in the chat on Rumble right now. And I don't know if there's anybody else in here. I'm going to give a shout out. We've had more people show up while you're doing that. Let's see. Angela Baby Carson is here. Angela, did you get my memo about the what I was talking about to all the moderators? We don't just time out because you don't like somebody or something. Okay. It has to be like hate speech or something that's really reprehensibly disgusting. Other than that, you know, let it go. Let it go. All right. So that's where we're at, moderators. So we got Access Monday, Derek Lemire, Dreamy Lynn, Escape the Chains, my Dreamy Lynn, Evelyn Deer, Freedom by Truth, Jency Tordai, Jonathan Kampala, Push Button 62, Sean Alkey, TJ Trusty, and of course our good friend ZXL Master. Welcome everyone. Looks like we've got 42 over here on the YouTube side tonight. And I don't know how to check how many I got on the damn Twitter. I got it on there though, going to. And it looks like I got only 6 over on the Rumble side, but that's cool. Let me see. Is this thing going to let me do anything? Let me ignore that and then send. It won't let me send nothing through that. So I'm sorry to people on Rumble if I don't respond to any chats over there. I'm having a little bit of a pooch problem here with the keyboard, as you know. So are we coming along there, Conspiracies?
Looks like it's not going to work. That sucks. I'm not ashamed by showing me, but myself. But
well, no, I was just saying it makes it. I mean, are you working off of a phone or a PC?
A laptop.
A laptop, okay, because you can also, you know, there's a share screen option at the bottom too. So if you have any material that you want to present, you can do it through that. You'll see a little, it says present, and there's a little TV screen with a cross in it or some shit.
Okay.
Looks like me. So do you have like a regular name that you want to go by, or do you like just want to go by, how about Smasher? Is that
No, you
cool?
can call me Mike. That's fine.
Mike? All right, Mike. And of course I said my name is Dave.
Yeah.
All right. So did you hear my thing about the planetarium?
Yeah. A planetarium is basically projecting what we see in 2 dimensions onto a curved 2-dimensional field.
Right.
Okay. We know that space is not 2-dimensional.
Well, right. That's absolutely right.
But what they do is in a planetarium is this just makes it easier. It's simpler to demonstrate what people will see at night and just project it onto a curved ceiling.
It's a replication of that.
Yeah.
Absolute replication. So the sextant would give you absolutely no different reading than if you were to go outside with the same objects.
Correct.
Yeah.
But the best
So
thing
now,
about
if you wanted to go from that to another point, you could actually check that as well, you know, just merely by changing the location according to what your prediction would be. Like if you already knew what the projection would be from another point, you could actually check that was right by merely moving the projection to be at a location where you just were checking to. You understand?
Mm-hmm. Sure.
So yeah, it would be absolutely. So it is absolutely impossible to tell the difference because you can actually simulate the movements of all these things right there on that flat 2D screen, that dome, right? So that's absolutely possible to replicate that.
Yeah. So one of the things I wanted to bring up was the sextant is a great topic. The sextant is used for hundreds of years to determine navigation on Earth using celestial objects.
Mm-hmm.
Okay. And over the last several hundred years, we've tracked the location of hundreds of different celestial objects in this night sky and even in the daytime. So,
well, you'd have to correct that really, because you'd have to say that you have tracked the movements of them.
Well, actually, track the location. I mean, so on a regular basis, you know, hundreds of years ago, they did it very, very rarely. They keep changing it. Currently, the current Naval Celestial database, whatever it is changed every year because, you know, after a while, so the location of stars change. And the more accurate your equipment is, then the more accurate you need the star location. So, like for example, Polaris, hundreds of years ago, wasn't even a celestial pole. It was a different star.
Yes, it was. There are monoliths around the world that are, in some cases, thousands of years old that have holes drilled through them precisely to look at Polaris, and it shows up exactly right in the center when you look through it, man.
What's the angle? What's the angle error of that hole?
I don't know what it would be mathematically. The fact that you can look through it at any point in time and see Polaris is the point of it.
Yeah, but I'm saying
it's always been there.
Okay,
it's always been there. It will always be there. There's no movement of that thing. They don't even, you can't, how would they even know how far away that is? That's what I wanted to get with. How do you know how far away these things are?
Well, you have stellar aberration, you have Doppler shift, you have parallel.
Well, wouldn't you first have to start with like some of the, all right, first off, you know, man looks up in the sky, right?
Mm-hmm.
And one of the things he notices, of course, is that there's this big yellow ball that comes by, right?
Mm-hmm.
And another thing he notices is that there's this big whitish ball that comes by in the dark, right?
Yep.
And they both appear to be the same size. Now, of course, primitive minds say, well, maybe the fire went out on it and it comes by after it went out again, you know, or whatever. So you're going to have that. So the wondering of what those objects are in the sky. Once you've ruled out that they're two separate objects, your next thing is going to be what? To find out how far away they are. How big are those things? What are they? Geez, right? So how do we go about doing that? How would we go about, like, there's the sun. This is something that gives us light and everything. It seems to be a very important part of our existence. So how far away is this thing and how big is it? So how would we go with that? How would we figure that out?
Well, I'm sure, like we've discussed before, parallax is an easy one. Radar.
Wait. Parallax. For those in my audience that might not understand what parallax is, can you just kind of give a brief explanation as to what that is?
You take a known object between the object you want to measure, and you take a known distance, like say if we know the distance the Earth travels in a month, in 6 months, in a year, and so we can then say, okay, well, we know the distance that we travel in 6 months, and so if we take the angle of the point in June and take another point in December, that creates a triangle. Okay, and so if you know the base distance and you know the two angles of each side, then you can calculate, simple trigonometry. You calculate the distance. You know what the distance would be.
No, it only shows from where your perspective of it is throughout a year. It doesn't give you a distance at all.
Well, no, trigonometry is if you have three values.
Yeah, I know about trigonometry, but you have to have some known values. You can't just go a squared plus b squared equals c squared and automatically have c squared. You don't get that. You have to have a known variable. Now you said you have to, like, a known object between you and the object that you're measuring is exactly right. You could do that. So what known object that you know the distance and size of between your observance point and the object you're measuring is it that you're using?
You can use any object. You can use the moon.
Well, which one? How would you know how far away or big any of them are?
Okay, let's say you determine that you want to use the moon as a basis.
Well, you don't know how far away that is either.
Okay, let's call it X.
Okay, X is an unknown.
Okay, so we know that the distance to the moon is X. Okay, and so we know at one point in time that there's a 90-degree angle between the Earth, the moon, and the sun. Okay, that's when the moon is the half moon phase.
Well, wait a second. That has yet to be proven that the phases of the moon are actually caused by the shadow, because you can't even get a curved shadow like that, man. You can't get a straight shadow at a half moon.
100% correct that the Earth shadow does not create a straight line like that.
So we're assuming now that these things in line with what? You're not even sure where you're on, right? It's in line with where you're standing, you mean? And we call that an eclipse, right?
No.
I thought you were talking about like when the two things line up right with you. Oh, okay.
Phases of the moon are not an eclipse.
Well, can you prove that they're actually caused by the sun?
Yes. One half of the moon is lit up by the sun. The other half is a big giant shadow. You'll
never get a straight Terminator line like that. You can try it all day long. I've tried it. You can't
do it. Ping pong ball.
You're not going to get a straight Terminator line like that. I guarantee you. Your ping pong ball, basketball, cue ball, I don't care. I've tried to replicate that before. Listen, I was you. All right. I was you one time. Believe it or not. And I tried to debunk that. And you can't do it. Not to replicate that what we see. So that's an assumption that is caused by that. We're still trying to determine the distance to the sun and the moon. How do you know they're not the same distance away?
Well, I'm getting to that. So when you know that, okay, so during a half moon, you have the half of the moon that's facing the sun is lit up, and half the moon that's away from the sun is in shadow, is not getting lit up by the sun. Okay.
No, actually, it works the opposite of that. When you actually track the movement of the sun and the moon is always approaching the dark phased side. Because look at you have two sides that go dark, right? During your different phases. Am I correct?
You have only
Okay.
one
You
side
get a
lit up and
crescent,
another.
you get a crescent that turns to a half, that turns to a 3/4, that turns to a full, that drops back to a 3/4, that drops back to a half, that drops back to a quarter, that drops back to a new moon. Okay. So the sun changed direction. It's always coming around the same direction. Right?
Yeah. Okay. No, it's not letting me share. Why isn't it letting me share?
Hang on, I saw something pop up on the screen down there. Do that again. Yeah, I have to put it up. If you share it, it comes up on my back. There you go. There's something. Yeah.
Okay. So here's your straight terminator line, right? You have a sphere. The sun
Right.
is to the right. Okay.
Okay.
So from the Earth, and you look out at the moon, you know that you're looking at one direction, and then 90 degrees to the right of the moon is the sun.
Okay.
Okay.
All right.
So in this situation right here, the angle on the moon is 90 degrees.
Okay. So now show a ball, take a ball, shine a light on it, and recreate that. I've tried, man. You can't. You can't do it. Now, here's the thing I noticed too. So when I get up in the morning and I see the sun rising, of course, I see it come from the east over the Blue Ridge Mountains, but actually it comes from more northeast. It comes from northeast. Okay. And then as it approaches me, it goes across the sky, right? In a southwesterly direction, kind of an arc. All right. Now, I have had crescent moons in the daytime, right? Early morning, where the lit side of the moon is away from the sun, which is coming up in the east, the northeast.
Yeah, that would be impossible.
No, yeah, it would be if that's what was causing the light.
No, but I'm saying is the situation describing is can't happen.
No, it's happened. There's countless video and picture. We see it all the time. Nobody ever thinks about it. I brought this up to people. I say, you know what's weird about that? And they're like, what? I'm like, if that's lit by the sun, how come the sun's to the left of the moon? So anyway, I have seen that, but we still have not determined that these two things of their light have the relation. We're still trying to figure out how far away they are. Right?
Well,
so you see this yellow light in the sky and you say, man, how far away could we go up and touch that? And, of course you're going to wonder that, is the first time you're seeing this thing and you know no information on it whatsoever. And you are hell bent to find out. Right. So you go, here's this sun. It comes every day. And it wanes out through the colder months and then gets intense during the warmer months. And, you have all these questions. So you're going to go, how far away is that thing? So you don't even know really what it is, but you got to figure out how far away it is. So what do? Again, you can only work, and this is what I was trying to tell you, Mike, in the Twitter, is that you cannot do that without assumed values. The 2 points you view something at in the sky on the earth, it just gives you a different angle that you're viewing that object from. It still doesn't give you a distance. So you can't calculate a distance because a large object moving very fast, far off, can appear the same as a smaller object at a closer distance going slower.
Mm-hmm.
And this can be easily demonstrated by just placing two different objects on a simple record. spin the turntable. The object closest to the rotation is going to be it's going to look exactly the same speed as the other one, but the other one is much further away, and even though it's got the same amount of RPMs, it's got a higher centripetal speed than the one closer to the hub. So this throws there's parallax. There's how parallax, but you can't really use the parallax if you don't know the distance to the object that you're comparing it to, that's between you and the point you're viewing.
That's why you test every measurement. So what you can do is, okay, so you do the first experiment and you have like what I was saying. Okay, so you make the assumption, okay, let's test and say, my first hypothesis is that the moon is lit by the sun, and at a half moon, it is 90 degrees. And
you're there again. You're assuming that the moon is lit by the sun.
This is a hypothesis.
Right.
We're going to test the hypothesis.
All right.
Okay. We're going to do a scientific experiment here. So we test the hypothesis, and we say that we know that the distance to the moon is x, and we know that that the angle created from the sun to the moon to the earth is 90 degrees. Okay, so now we're going to take a theodolite and we're going to measure the angle between from the earth, from the moon to the sun. Okay, so we're going to complete the Pythagorean triangle. Okay, and so if I have a 90 degree, I have x, and I have 89 degrees, 58.6 minutes of arc to the sun between the moon, we now have three values, and we can calculate what the fourth value is, the distance to the sun. Okay. Now, if those are all true, then we do the math and we come out to about 400 x. Okay, so the value of the distance to the sun is about, give or take, about 400 times the distance to the moon.
The shadow experiment.
Okay. So there's our first test. So now we know. So now we're going to assume that the sun is 400 times further than the moon. Okay. Now
why would we assume that? If it works out with them both at the same distance, why would we assume that it's 400 times further away?
The experiment and the math came out that the sun would be 400 times further than, because we know the distance to the sun to the moon.
No, we don't.
Is x.
Yeah, that's x. That's unknown. Okay.
We know that the angle from the sun to the moon to Earth is 90 degrees. Okay.
No, not always. That's not.
We're using isn't it? This is a hypothesis. Okay. We're
right, but it's going by a false premise because it's not 90 degrees. It's different all the time.
You don't know. Okay. What we're saying. What do you mean different all the time? We know the sun, the location of the sun. We know the location of the Earth is 90 degrees from the moon. Okay. We can follow the two. We can look at the two. We can look up in the sky and say, okay, well, there's the moon, there's the sun.
Mm-hmm.
We can measure the angle between the two. It's 90 degrees. Okay. We know that the sun is lighting up half the moon just because we can see that it's 90 degrees apart from each other. Okay. And then we know that when the moon gets further and further away from the sun, we know that the amount of the moon gets lit up more and more and more. And we know that the moon is 60 degrees away from the sun in the sky. And we know that more of the moon is lit up. Okay, so obviously something is lighting it up and the angles are matching up to the phase of the moon.
So in other words, then you get the wider angles from the moon and the more parallel rays coming from the sun. And this is going to give a good indication, right?
Yeah. So now what happens when the sun sets? What happens when the sun sets and 20 minutes later, the moon rises. What phase of the moon is it?
It's whatever phase is dictated by the month, by the day of the month. It's on a complete 28 cycle.
Every single time when the sun sets and the moon pops up 20 minutes later, it's full.
No, that would mean you have a full moon every day, and you don't have a full moon every day ever.
Wait. How come we don't have the full? We don't have every day where the sun sets, the moon rises 20 minutes later. We have phases of the moon. It changes.
We have sometimes where the moon is already out before the sun comes up, and the sun comes out, and the moon is there at the same time. That's what I've said.
That's what I just told you. That's right. That's what, as we move from when the sun is 90 degrees to the moon, okay, at a half, and then we go down the next day, and the next day, and the next day, and the moon gets fuller and fuller and fuller because the angle from the moon to the sun is greater. And
yeah, but that changes. That moon distance changes from your perspective all throughout the month.
Correct.
I mean, it goes lower in the sky and then higher in the sky.
Right, because the moon moves across the sky slower than the sun. So every day that the sun sets, the moon moves from very close to the sun, having a very, very tiny crescent, to moving across every day. Then the next day, the moon is a larger angle away from the sun. And then the next day, the moon is even a further larger angle from the sun. And then 7 days later, after they were almost to each other, we now have a half a moon. Okay. And then 8 days, 9 days, the moon's getting more and more fuller. And then we get to the 14th day, and we have the moon is not even visible when the sun sets. Okay. Once the sun sets and the moon rises, we have a very bright full moon. Okay. Then as the sun, then all of a sudden we go, and the only time you'll ever see the moon after that is when the sun is already set and it's nighttime. And then it goes from full to less to smaller, smaller, smaller. Day 21, in the middle of the night, the moon is a half, but on the opposite side. And then what if that could be refuted though? I'd love to see someone refute.
All right, cool. Okay. So this is kind of interesting.
Sean makes an interesting point that first off, phases of the moon would be impossible on a flat Earth because you'd never get the alignment.
Well, that's because you're still assuming that that's the sun reflecting off of the moon. That's the sun lighting up the moon.
Well, I told you we
contend that the moon is its own light source.
Wait a minute.
And it goes through those phases.
Wait, the moon is its own light source?
Yeah.
How does it?
Yeah, absolutely. Well, it's real simple, man. I'll show you in just a second. Watch this real quick, and I'm going to pull something up. Let's see. I got the sound. Everything's good. All right.
The Eratosthenes shadow experiment is used as a proof that the Earth is a globe, but moonlight creates the exact same shadows as the sun, which completely disproves this experiment. But before going into more detail about this, I will briefly explain Eratosthenes' experiment for those who may not know about it or forgot what it was. Eratosthenes noticed that at the same time on Earth, shadows are of different lengths and angles depending on where you are on Earth. He then wondered how this was possible and ultimately deduced that this is only possible if the sun's light comes parallel to the Earth, and the Earth is a curved surface, as shown in the diagram. However, the sun's light can only be assumed to be parallel because the sun is claimed to be 109 times larger than the Earth. But this then creates a paradox, because the moon also casts the exact same shadows as the sun, and yet the moon is only supposed to be a quarter the size of the Earth. The problem is, if the moon's light is assumed to be parallel, it will only illuminate a small portion of the Earth. But we know that this is false. Half of the Earth is supposed to be able to see the moon at any given time when the moon is illuminated. And so half of the Earth should also be illuminated by the moon. But by assuming parallel light from the moon, half of the Earth would not be illuminated by the moon. So the moon's light cannot be parallel, but it has to be if the sun's light is supposed to be parallel, because they both must create the same shadows. The only way that the sun and the moon can create the same shadows is if both lights act in the same way. And only the flat Earth model has both the sun and the moon illuminating the Earth in the same way. Both are radial lights that are smaller and closer to the Earth than in the globe model. So by also considering the light of the moon, only one model allows both the sun and the moon to cast the same shadows, the flat Earth model, while the globe model cannot account for that.
So, and also you have to look into this too, is that this also means that if this also means that people in different parts of the world would see different moon phases. If what you're saying is true, they would see different moon phases because they'd be seeing the moon from a different angle, and the crescent would be pointed different angles, and it doesn't never work.
No, because of the distance of the moon, they would all see the same phases.
Well, see, we don't know the distance of the moon.
Well,
that's the whole thing. We haven't determined the distance of the moon because
local, then
well, how do you know the sun isn't local as well?
Okay, if the moon is local, then we know that different people on the Earth would see different phases. Okay, you're seeing a ball in the sky, however many thousand miles up. Nobody
250 is what they claim.
250
quarter
miles?
of a million miles.
No, I'm talking about on a local moon. How far is the local moon?
What they're telling us is 250,000 miles.
No. The local moon. You say you want to claim a local moon.
Yeah.
How far is a local moon?
Oh, I don't know. I never went there.
Okay. So
Nobody
let's say it's 3,000 miles up.
All right, let's say that. Why not?
Okay.
I can say whatever. It doesn't.
So if Los Angeles and New York are 3,000 miles apart, okay.
Okay.
Or even better, Los Angeles and London are 6,000 miles apart. Okay. Would they see the same phase? Would they even say the same size of the moon?
How far apart are they?
Let's say 6,000 miles.
Where in what locations?
Los Angeles.
No, Los Angeles and where at?
London.
In London. It would depend on what time of the year it was. There's not much difference in latitude there, so they would see approximately the same one. The one you'd want to really check with would be the guy looking at the moon in Nova Scotia and the guy that sees the moon, say, in Mexico. Okay. Because now what we've got a problem with is the height of the sky it's going to be, right? That's going to dictate where it's at along its route between the Tropic of Cancer and the Tropic of Capricorn. It phases between those two tropics, and it's 28-day cycle around monthly. Okay.
So if it's a sphere, like the ball you have on the top, right? In your pig, okay. If it's 3,000 miles away, then you have a guy standing 45 degrees to the right, and a guy standing 45-degree angles to the left of that sphere. How much of that sphere are they going to see in common?
If they're 45 degrees from that sphere, they're both going to see probably about 180 degrees of it. Or at least 90. I don't know. What does that mean? The light perspective, from what you're saying, the light perspective would cause somebody to see, like in Nova Scotia, would see one type of a phase, and somebody all the way down at the tip of southern Mexico, right where Central America starts there, they would see a completely different phase. But secondly, you have to look at the ridiculousness of thinking that much light can be reflected back onto the Earth from a dusty gray rock.
Okay, let's not change the subject.
I'm not changing the subject. I'm just saying that.
I'm talking about. I want to discuss the angle of the moon. Okay, so you have. Let's use your ball and top pick there.
All right.
Okay. So you have a guy 45-degree angle to the right, and he sees these two vertical lines on the moon. let's say, right? You see
Okay,
those
you're
two
talking about
vertical
the ones. You're talking about the ones up here at the top right, right
Correct,
here,
right?
right? Okay, he
Okay.
sees those. This guy over here, this guy over here wouldn't probably see them at all.
Okay. So why does every human being on Earth see only the same size of the moon? Same side?
Yeah, isn't that interesting? Why? Why
Because
do we only
because
see
it's
the same?
250,000 miles away.
I know. If it's really that far, I don't think it's that
Okay.
far. I don't think you could see
But
such
if
clear
it's
detail
but
from
if
that
it's
distance at
local,
all. Not with the
but if
human
it's
eye. I mean, you can see some serious detail with just the naked eye, you know?
correct,
So
right? So we
that's
can
kind of
see
sus, you know, 250,000 miles. I'm being able to see that. Yet if I get more than fucking 15 miles above the earth, I can't hardly pick out any detail of anything on the surface of the ground, man. So that's kind of gives me an
no, we're
idea
talking
that it's rather small and close in comparative to what they're telling
but
us.
it's
I
only
can tell you
1/6 the
that.
size of the Earth. Okay.
Well, that's what we're told. Yeah. And that's what's in question. Now, how the hell
Okay.
did they ever determine that? You can't gonna tell a distance by looking at phases of a moon.
No, you could tell. You do the simple angle. You know the velocity. You know the angular velocity of the moon.
Well, there again, you're assuming that that's a ball that you're seeing up there. But as we've discussed before, a ball does not reflect light like that.
Why not?
Okay. Why not? Try it. Try to take a light and make a full basketball or a full bowling ball. You won't do it. It's going to do like the one up on the top. You're going to have a specular highlight at the source of the light, and it's going to
Right.
fade until it doesn't reach around the ball anymore. It's
Right.
that simple.
So what's the source of the one on the bottom?
I don't know
Where
what the
is it?
source of it is. It's its own source of light.
We know
As the
exactly.
same. Hold on, wait a second. The same as we have the sun as its own source of light, right?
Yeah, but the sun doesn't have any shadow. The sun
Well,
doesn't have
that's
any.
right, because it's a very, very bright light. This one's
Okay.
a lesser light. It's not reflecting sunlight. That's proven. You can't reflect light off of a ball that way. Okay, you can't. I've seen lamps. I've had lamps that are globed lamps that have detail on them, and they have a light on the inside of them.
Okay.
So you're showing me this, which is the very thing in question.
Okay. Show where is the source of light in that picture?
It's the moon itself.
Okay. How do we have shadows in the craters? And how do we
I don't know. I don't know that those are craters or shadows. All I know is it appears to be craters. I don't know what those are. In fact, what it looks like to me, if there was to be any kind of a reflection, it would have, in order for it to show up like that object would have to be concave. Only a concave object round like that will reflect light or give off light that way. That's no other way around it. You are not going to shine light off of a rock and have it reflect light back to the earth in a bright enough fashion, or even at all, to the point where you can read a book, you can read newspapers under full moon, you can see clear. It's almost like a surreal daylight.
Mm-hmm. Yeah.
So that's not, and also here's another indication too. I had solar panels when I was out in California. I lived in the Mojave Desert, and I had solar panels, and my meter would be going, I was getting all kinds of good shit during the daytime.
Mm-hmm.
And at night under a full moon, there wasn't nothing, not a spike. Nothing.
What is the source of your power on a solar panel?
So the sun.
Okay, what literally is powering the solar panels?
Well, it's picking up it's a thing it does with boron, is what I'm told that the solar panel does. But as a reaction to sunlight, which
Right.
is what you're
Ultraviolet
claiming
light.
is reflecting off of the moon.
It's the ultra. It's not okay. Ultraviolet light.
It's not ultraviolet. Stop. Just stop. That's made up. Stop.
It's made up.
That's made up. It's not ultraviolet. It's a reaction with the fucking sunlight.
That's what ultraviolet light
Okay.
is. That's what
All
causes
right.
sunburn.
Yeah, and it's infrared as well. There's a whole host of light
There's a
within
spectrum of light,
sunlight.
but-
Okay. Never mind. All right.
You
So
have-
reality
you
of
have-
it is, you don't get so much as a bit of a reading. Okay. Now, if what you were
Exactly.
saying is
Because
true,
it's not the
if
sun.
what you were saying is true, when there's cloud cover, I still picked up solar power.
Exactly. You know why?
Okay. But you know
Clouds
what?
don't stop
That was
ultraviolet
because
light.
it was the sunlight and it
Clouds
wasn't
don't stop
moonlight.
ultraviolet lights. The rays, the waves of ultraviolet light can go easily through clouds.
Oh my
Okay,
word.
light enough clouds. You still see daylight, right? It's cloudy.
You do
out.
you realize the amount of mental hoops you're having to jump through to do this, right?
No,
I'm just saying, I'm not being mean. I'm just saying that's a lot of fucking hoops, man.
Okay. Well, saying no.
No, I'm just saying. I'm just saying. Look, no, I got intimately acquainted with and made friends with the guy who did my solar panels. He was really cool. He was actually a Paiute guy, and how the shit works. I have all the information still on it and everything. All of the papers that came with it, all of the readings that you were taking, dude. It's it's not sunlight on the moon. It's just not. And also using the inverse square law of light. Okay. Now you got to think about this.
Inverse
The amount
square
of
law is a
lumens.
math formula.
What's that? I got a real good demonstration of it.
Inverse square law is a math formula.
Yes, and it's actually applicable, and you can actually show a demonstration of it. It's real cool. You can show a demonstration of the inverse square law of light.
Okay. Yes, I understand. I know exactly what it is. Okay.
All right.
So what is your beginning value that you're using?
All right. There you go. What I'm going to just give to you is just think about this: the amount of lumens, whatever they may be, that are enough for you to read, that's enough to illuminate all of the earth where people can see it, right? And it's like it is there. Now you use that inverse square law of light with that amount of lumens and take it that 250,000 miles. Okay. And you know what would have happened? Those dudes, if they actually had gone up there, which we all know they didn't, that is so fake. I mean, Christ almighty.
Okay.
But it would have burnt their freaking retinas out just to look at the ground. I mean, it's just, it's ludicrous.
Okay,
it really
that's not how the inverse square law works, but
well, yeah, it does, because with that, because light diffuses over distance.
Okay.
Light diffuses over distance, man. We know that.
Okay.
This is why I'm saying these stars and shit, there's no way you could see them if they were as far away as they tell you that they are. There's no fucking way you could see them.
Okay. Well, saying inverse square law without providing the values of the inverse square law is
a demonstration of it, whatever value, use whatever value. How about just guess at one? We just guessed at the fucking distance to the moon and shit. We also assumed that it was the sun that makes the moon fucking light up.
Yeah,
right? We're assuming things. Just say it's 50 lumens. 25. Go with 25. Even a low number is going to give you. Even a low number is going to give you retina burning values by the time you even get close to it.
Okay, what if it's 100? What is the lowest lumen you need to be able to see light?
Oh, I don't know what that would be.
Okay, so what if it was 1/100th of a lumen?
Well, why don't you? Is there validity in what I just said?
No.
That as you got closer to it, over 250,000 miles, that it would be extremely fucking bright by the time you even got close to it, because of the inverse law, square law of light. All we have to do is work it backwards.
Okay.
Here's a demonstration. Let me just do this real quick.
Okay.
I'm going to show a demonstration of how that works, just for people it's not really apparent. And you have to also know, you'll notice too, as this happens on this demonstration, that the light gets dimmer. Okay, so we have to go further and further with it, but I'm going to show you this, and this will help some people to understand. Oh wait, did I oops, I grabbed the wrong one. My bad. I grabbed the wrong one. Hang on one second. This is the one I wanted. Is it? Oh yeah, it does. Okay, it is. It starts this way. My bad.
Okay, that's the glare going smaller.
That's all right. He gives a demonstration here. The music's kind of like, feel like I'm in an elevator or on hold.
Okay, I can't hear him talking if they're trying to get that. I don't think it's playing. Now you're muted. I can't hear you.
Oh, my bad. Yeah, hang on a second. I got this. All right. Let me try it this way again. Maybe it was because I was muted. Let me just present. What does it say? Browser block the screen. Okay, good. So share screen. Damn it. All right. Let me back it up to here. Let me hear. Can you guys hear this?
So I can project this square up on the board.
Okay, a little bit barely.
The projector is 1 meter away from the wall. So what I'm going to do is I'm going to mark the outline of that square on the wall. And now I'm going to move the cart so it's 2 meters away from the wall instead of 1. This is a 2 meter long stick. Away. Again, I'm going to outline the lit box. And now I'm going to go ahead and I'm going to move the projector so now it's 3 meters away. Now I'll trace the outline again, and then we'll turn on the room lights. And I'll turn off the projector. This was at 1 meter. That amount of light was hitting the board, concentrated in that area. But when I move the projector twice as far away, so it's at 2 meters, you can see that the same amount of light was spread out over an area 4 times larger. So the light is less concentrated, it's less bright. Same amount of power, same wattage of light, same luminosity, to use the astronomy term, is spread out over 4 times the area. And when I move the projector to 3 meters away, then that same amount of light was spread out over 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So the brightness of the light must be 1/9. If you triple the distance, the brightness of the light source becomes 1/9.
So all you'd have to do is if you work that backwards the same way, you get that. So whatever lumens you get, I guess if you have a light meter, you could go out and figure that out. I don't happen to have one handy right now, but if you happen to get into that, but it wouldn't matter. You can even take a low amount of lumens and work it, backwards to the distance that they propose that this thing is at. And you'll be able to see quite quickly that this thing would be like a bright ass sun, pretty bad. But another thing too is with the assumptions. And here's the thing: I understand, Mike, where they come from, and they slip them in on you real easy. It's easy to assume that light on the moon comes from the sun, but we see some things like anomalies I've seen, demonstrations, of how light even works. We see that there's it's not that.
Okay.
And you have to also, to take into account in the scientific method, you still have to take into account, okay, I believe that that's what's going on, and it seems that is how it works, right? You can assume that, and you can put a correlation to it. But I'm going to give you an example of one of those types of correlations. Every day during the week, there's a car that goes down my road at the same time. And it's a little red sedan goes by every day about the same time. And shortly after that, the mail truck comes to my mailbox every time. So I could draw the conclusion that red car going down my street causes that mail truck to show up at my mailbox.
Mm-hmm.
You see, we have to rule out that which we think is absolute. And when we find anomalies that preclude that absoluteness, then we have to look and say that, oh, that is not the only explanation for that. Because after all, despite the programming we've been given, we can't rule out the prospect that the moon is its own light.
Okay.
Because even hold on real quick, and then I'll let you go, because we can even go back, and I don't ever use the Bible as proof of anything, but I think it's awfully interesting, the wording. They waited until the sixth day to create the sun and the moon. What the hell was it orbiting around, and how was their light, right? And that's a question, but it does say, he said he created a greater light to rule the day and a lesser light to rule over the night. And a lesser light, not a reflector, not that.
The point I was trying to make though is in science, and I was trying to bring this up with the moon, and I don't know how we got six topics from that before I got a chance to finish it.
Yeah.
When we have experimentation for measuring, we have a number of different ways to measure. Okay. So what we do is, step one is to make a hypothesis on the distance, make a hypothesis on various values, and come up with a number. Okay, and like I said, we did a hypothesis saying that the moon is X distance away, that the half moon is a 90-degree angle to the sun, and we can test this. We know exactly the angle that we see.
The angle. Right. That's all you know.
We know that we know two angles. We know two angles, and we know a distance. Okay.
Well, wait, no, you don't know a distance. You assumed a distance.
We know the distance. It's X.
Well, yeah, but that's an assumed value because it's unknown.
Okay. But our answer, when we take a theodolite and we measure the exact angle between the moon and the sun, okay, and we apply that angle we apply the 90-degree angle, and we
Mhm.
apply X, okay? So simple
Mhm.
trigonometry, we can then come up with what is the last leg of the triangle.
You
Okay?
get an angle. You
No,
don't, dude, you don't have any values for the distances
you have
of
three
angle
values.
between you don't have any values for the distance of angle between those objects. All you have is a triangle.
Okay,
Have you ever taken descriptive geometry?
okay,
Hold
trigonometry.
on, wait a second, because I'm going
Simple
to tell you what's
trigonometry.
really interesting about that real quick.
Okay,
All right. So in descriptive geometry, y'all can see this pen, right? Okay. So I have this pen here in my hand. I'm going to pull myself up full screen real quick. All right. So I have this pen in my hand, right? So in descriptive geometry, if this pen is like this to your point of view, okay, right there in the thing, you only see it laying at an angle. You don't realize that it's actually laying at an angle to you and back in a z coordinate. Okay. And so what you do in descriptive geometry, it's a way of plotting something out to bring it with its true slope and shape to the plane and not just to your perspective. Now, even in that, you have to have known values. Okay. In other words, I have to know the length of the pen. Okay. And the angle of view that I'm looking at it with. All right. There's known values there. When it comes to these celestial bodies, we have no known values. The sun and the moon appear to be the same size. Occam's razor would then say, and in our experiment with the guys first trying to figure it out, right? So what would that mean? That would say that, well, apparently they look the same size, they travel in the same paths. I wonder, perhaps they are the same size and the same distance apart. Why would anyone think anything different based on their observations? And yes, we see them change distances in the sky with these vast distances that we claim. We shouldn't have that. It shouldn't appear much smaller in the winter time to me than it does in the summertime, but it does. And it's lower in the sky. Why? Because it's down closer to the earth than they tell us. And it's way down over the Tropic of Capricorn. That's why it stays dark most of the day up here in the north. And then as the thing comes back toward the Tropic of Cancer, then we start getting to where here we're coming up with tomorrow. Tomorrow is the longest day of the year, winter solstice.
okay.
Exactly 6 months from the last solstice when it was the darkest, shortest day of the year. Tomorrow is going to be the brightest day of the year. Why? Not because of some kind of a tilt. That sun's way bigger this time of year than it was back in December.
Well,
Provably so in photographs and everything.
unless you're in the southern hemisphere.
No, I mean, just even from here. Well, yeah, if you're in the southern hemiplane, if you're in the other half beyond the equator, what we deem as the equator, which is the midway point between the two tropics. Yeah, we're at the equator. What they call the equator line is the midway point between the two tropics. Absolutely. And if you're on land, if you're land down in the south, you're going to see the sun in the north. The sun is always going to be north, going from northeast to northwest. Okay. Whereas here here above this tropic, here above the northern tropic, we see it go from southeast to southwest.
Yeah, that's not right.
It's in an arc.
Okay, well, my time is running out, and I had like 100 things to talk about, but I kind of like.
Well, go ahead, take on. And
okay, so anything before I leave, let me close out. The whole idea of the science experiment is to come up with values that you can test. So, for example, we know in trigonometry that if you have three values, you can come up with if you know that there were two angles and a side, you can come up with the opposite length side. And so, taking that formula, so if we know the angle to the sun and moon, we know the angle from the sun and the earth on the moon, we can come up with the distance. We can come up that it's the 400 times the value of the base side. And so the base side is X, so we know that the distance to the sun is 400 times further than the moon. Okay. So now we need
Oh,
to
I'm
test
sorry.
this
You're still-
hypothesis. So we're going to test this hypothesis, and we're going to go and we're going to say, okay, now let's take parallax, and let's use parallax and say, okay, if we know that our distance that we assume travel around the sun, and we know the distance of the moon.
There again, we assume travel around
We're
the sun.
testing a hypothesis.
All right.
Okay. So we come up with then we come up and we say, you know what? We come up with the same value. Okay. So we tried 2 different ways and we came up with the exact same value. Okay. So let's try a third way. Okay. So now we're going to do the angular velocity of the sun. Okay, so now we know the formula of the angular velocity of the sun, and we know the assumed distance. Okay, so it's a third hypothesis, and we come up with the exact same value again. Okay, so now we have 3 different hypotheses, and we're coming up with the exact same value. Okay, so now our confirmation is getting a little bit stronger and stronger. Okay, let's try a 4th way. Let's try laser. Let's try radar. Let's try a different number of
All right.
different
Now,
things.
there's no laser or radar could ever fire anything the distance they claim to the sun. Now, listen to me on this, because I hear this all the time. I hear this all the time, Mike. Just real quick, it don't take a whole lot. You fire this thing, it takes 8.5 minutes for it to reach the target, which takes another 8.5 minutes to rebound back. All right. Overnight. All right. No, wait.
What angle does it bounce
now, it's not going to angle over 18,000 fucking miles for you to receive.
Degrees.
By the time it even got back, if it did dissipate out to be 18,000 miles or more wide for you to receive the signal, you would not even be able to detect it amongst the background radiation. That's never going to work. There's no laser is going to work.
They did it a dozen different times, a dozen different ways, 3 different locations.
Wait a second. No, that's what I'm saying, Mike. Mike, you're being smart through proxy. You're being smart through proxy. Now stop. You just said that they have done this. You have not done this. You've not even met these people that have done this.
So I can't say Africa doesn't exist. Okay.
No, that's absolutely right. That's absolutely right. But if there's only a handful of people that have ever actually done this,
and
that's all there is. This is the only ones they have. And their only proof is they think that there's some kind of a spike that they see or some other shit like that. Listen, we're talking about 17 light minutes of travel of a radar beam. Where in the world does anyone have the transmitting power to transmit a radar signal that would go that distance?
I sent you the link, and it had all the details and values, and I didn't hear a single word back.
Yeah, it was a bunch of fucking math. It doesn't mean anything. We don't live in math, Mike. We don't live in an equation, man. Just to point out, where you said in that whole thing about your hypothesis, it's still whether or not your hypothesis, and it didn't work out in 4 different ways. It doesn't even work out in one way in reality.
Well,
because the same thing, you can get the same results of it with a local sun. All of these things can get the same results with a local sun, a local moon, and absolutely, even Aristophanes' stupid experiment. That thing right there even is assuming a distance to the sun and assuming that light rays come in parallel.
Yes, he measured light rays. He measured shadows across a large field and measured the angle to those shadows, and they were literally parallel. That's how you test. You have to test your assumptions.
Okay, all right, we'll go with that. We'll go with that.
Let's say he did 4, 5, 6, 7 different points. Let's say he tried 10 different latitudes. Okay, if he had tried 10 different latitudes, we would have 10 different heights to the sun, 10 different distances to the sun. Okay.
Well,
Is
yeah,
that-
they've come up.
that-
There's been
that-
hundreds. Listen, they've changed the distance of the sun
Okay,
since they
no.
started this heliocentric nonsense.
I read that meme also.
No, it's not. It's not a meme. It's
It's-
not a meme. That shit is verifiable. They've
Okay.
changed it a bunch of times. In fact, one of the saints of globedom, one of the saints there, Newton, when there was an argument between I forget who it was. There was an argument between two of them over what the distance of the sun was, and he said whether it be this one or that one, it doesn't matter. It suits our purpose.
Yes, because
Real
it's
science.
85
That's
million and 93
scientific.
million. And so it suits her purpose that it was a distant sun, that the experiment that he was working on.
No,
So, yeah,
no,
but-
it suited the purpose and snowing people into thinking that you're a little fucking ball going around a fire gob out in the middle of space or some shit.
Okay. Okay.
Watch, here's even just a real cool thing. This is kind of cool, real quick. I'm sure you got time.
Gotta go. I mean, I am way over. So I want to appreciate you. Thank you for bringing me on. I really appreciate it. I definitely want to do this again. I want to kind of stick to a few topics and not bounce around so much. Because
it's kind of hard. It's hard when there lies.
Explain, and then I get instead of getting a valid refutation, I'm just getting I just don't believe it, and so it's really hard to try to explain my point. That I have to wait until the talking is done before I can kind of bring my point. So again, I definitely want to do this again. I definitely want to keep going. This is great. I really appreciate
it's
you
a lot of
bringing me
fun.
on. And
See, this is the thing, man. Come on, Mike. You see how we did this tonight, right? We didn't have to get mean with one another. We didn't end up throwing feces at each other like a couple of damn monkeys, right?
But
We
like I
present
said, though,
our
we have
sides
to-
and we present
have
our
to be
arguments. I
honest
think
with
it's
each other,
awesome.
though, that when we have different experiments and different stuff like this, I've done the Artosmy experiment personally. I've validated that. I've done the 90-degree angle to the sun. I came up with 390 plus times the way further than the moon.
It'll work on a flat plane too, though,
It
Mike.
cannot.
Yes, it can.
Cannot.
Absolutely, it can.
And then also on a flat plane, you also if the moon and sun were the same size.
What if
you'd
one
have
of your
eclipses
saints?
every 28 days. But
What
I
if,
gotta go.
what if one of your saints actually agreed with that? Agreed with me.
I doubt that. Post
Yeah.
it on Twitter. Let me see your proof. I'd love to see it. But
Yeah.
good night. I gotta go. And
Hey,
again, let's do this
real
again.
quick, Mike. Real quick.
Yeah.
If you're available Saturday night at 9:05 on this channel, we're gonna have Bill and Ted. They're gonna be coming on. We're gonna be doing a show together, and then I'll shoot you a link if you want, man.
Hey, we'll see. But yeah, they're not the brightest.
Oh, I don't know. They got some pretty good shit out there. I've been having a good time talking to them, even off platform.
Oh,
So
my.
yeah, man.
Okay. So
All right. Good night. Good night, Mike. Thanks for joining us.
All right. See ya.
All right. So anyway, I was going to show him this. One of his priests actually agrees with me. If you want to see real quick.
Is the Earth flat or round?
It's not okay to say that the Earth is flat. It's not okay. We've taken all these amazing pictures from space. They're so beautiful. All the
Pictures from space. Those pictures are not fake.
We have video of the rotating spherical Earth.
So I don't really know what's going on right now with this Earth is flat thing.
Not everybody can be a robot polisher.
One of the things you can see yourself, if you actually go out to a lake and there are boats on that lake.
See, the bottom of the ship is gone. Now we can see midway up, and then
It's no longer visible beyond your horizon.
And that's because the boat is actually going over the horizon that's curved. That wouldn't happen if the Earth were flat. As the boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And that's because the boat is actually going over the horizon that's curved. And that means that as it goes farther and farther away, you see less and less of the bottom of it and more of the top of that.
Mic drop.
That wouldn't happen if the Earth were flat. You would simply see the boat getting smaller and smaller and smaller as it went farther away. You'd be able to see the whole thing with the same proportions. That wouldn't happen if the Earth were flat. That wouldn't happen if the Earth were flat.
so the process of testing claims, the world is flat, the world is round, is what we call science.
What is science?
It's a famous experiment conducted by Eratosthenes.
And Aristophanes noticed that there was a town called Syene, and on a certain date, the sun would actually shine straight down to the bottom of a well. That meant the sun was directly overhead. You could look down a well and see the sun shining back at you. And on the very same date, farther away in the city of Alexandria, that didn't happen.
How can we use this observation to see if Earth's surface is curved? We need another well. Turns out we can't see the bottom of both wells at the same time. What might explain this? Well, there are two possible explanations. First, we could have a flat Earth with a sun that's small and close by so that the light hits the second well at an angle. Or second, we could have a curved Earth with a sun that's big and far away so that all the light comes in parallel. With a sun that's big and far away so that all the light comes in parallel.
In science, we always say that you make observations, you have a theory, you can go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
If you have a claim that can't be tested, that's what we call pseudoscience.
He didn't know what gravity was. Einstein gave a better explanation. We're probably going to get a better model later.
We're
looking at light, and we are understanding about the materials, right? We're understanding the composition of things based on light. We're understanding the composition of things based on light.
The difference between pseudoscience and regular science is whether or not you can test it.
No, they can't observe. It's too far away. It's too theoretical.
You have no idea. Okay, next question.
You cannot reproduce the Big Bang, but you can then trace the history of what happened afterwards, like a murder mystery. And that's where a lot of science is done. All the things that were once considered science fiction are now centerpiece in our understanding of the nature of everything.
It's all science fiction.
Tesla had something to say about those guys. He said, today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality.
Science and science fiction are essentially the same.
Science delusion is the uncritical belief in these dogmas, treating them not as beliefs but as truths. It's a conflict between science as a belief system and science as a method of inquiry, which is about finding out what we don't know through systematic inquiry, the experimental method, hypothesis, and so on.
Empirical evidence tells us that either the surface of the Earth is a flat plane or the planet is at least 100 times bigger than we are told.
Science!
And not everybody can be a robot polisher.
That academia, as the holder of truth, plays an essential role, particularly today.
So I thought that was pretty good.